yes, you're a good boy. Hey, stop pacing. We're shooting a movie here, okay? You want to be on a movie?
Hinges Creek is on YouTube, but Hinges Creek is on YouTube, but Hinges Creek is on YouTube, but Hinges Creek. Ho, ho, ho! Hinges Creek is on YouTube, but Hinges Creek is on YouTube, but Hinges Creek is on YouTube, but Hinges Creek.
Alrighty. Welcome everybody to the next episode of When Hinges Creek is on YouTube. Hey, hey, hey. Never gets old. So, before me on these tables, this is where all the design work for our new haunted attractions is going to go. In the old days, we used to design in AutoCAD and on paper, and what we discovered as time went by is about halfway through the design process, we would want to revamp and adjust, and one of the fastest ways we discovered to do that is what we called sticking it out. In real space, what we do is we cut long strips of wood that are 4 feet long and about 4 inches wide, and we literally lay them on the floor just to kind of get a sense of the space, because it was very common. We would follow our CAD drawings, and as we started laying lumber out, we would find very often that it's like, it just doesn't vibe very well. And just rolling the super dog is big. Yes, you're a good boy. Hey, stop pacing. We're shooting a movie here, okay? You want to be on a movie? Yeah. So, anyhow, what we're doing as far as getting our rough layout is we're using this grid paper. Now, this stuff I got on Amazon. You can get a 3 foot wide piece of it. So I had to cut an additional foot, and I glued it down to these Lewin sheets. But this gives me 96 inches by 48 inches. And what this gives me is 1 inch equals 1 foot. And this is kind of how we get our general layout of the structures on the ground. So one thing that we need is a stand-in for a wall panel. And that way we can, lay our walls out however it is that we want. Things need to be reasonably accurate, though. Within reason. We don't have to necessarily get down to like microns on any of this stuff, but it needs to be pretty close. So what we're doing is each wall is being represented by a popsicle stick. And the good thing about popsicle sticks is they're plentiful and they're cheap, they're light, they're affordable. You can get them just about anywhere. However, the problem with popsicle sticks is they range between 4 3/16 of an inch long up to 4.5 inches long, and I need them to be exactly 4 inches long to represent the 4 foot wall. So I found a very fast, cost-effective way to make sure that these are all 4 inches long. So follow me to the machine. Pardon the mess in our production facility. We are, of course, in the middle of getting ready for the new location. Come run over to this side. Okay, so welcome to Reindeer Manor Entertainment Laboratory's smallest machine shop in the world. We have our little mini lathe. We have our mini mill, we have our little tiny bandsaw, and our arbor press, and of course our fire extinguisher right in the middle of the table. And if the fire extinguisher is not part of your general tools and or equipment, you probably want to resolve that. Fire safety is a very, very important kind of thing. So what we're going to be doing is placing a bunch of these inside the mill, and we're going to be milling all of these down to exactly 4 inches long. First thing is safety. I've gotten to the point in my life where reading glasses are kind of a must. However, for doing this kind of work, they don't really offer the protection that one needs. So if you know the strength that you need, you can actually get safety glasses on Amazon that have a reader built into the bottom. So nothing says I'm gonna get the attention of the lady folk quite like safety glasses with readers built in. So for those who don't know, this is a milling machine, and I know it looks very similar to a drill press, and in some ways it is similar. There is an adjustable quill that can be adjusted up and down with this turn handle on the side. However, your basic drill press is really just designed for loads to drill straight down. They're not really designed for side loads or anything. So full disclosure, I am not a machinist. I am not even really what you would consider to be a seasoned machine operator. This is still very much a learning process for me. So the way this device works, and piece of full disclosure here, this is actually not how you want to hold this tool. The real one of these is coming from Amazon. So because this is very soft stuff, this is what we're using today, but you don't really want to use a Jacobs chuck to hold an end mill or a side mill. This thing, of course, spins, and what this machine actually does is you can drop a spinning tool down, and then you have several axes that you can work off of. You have, let's see, your x-axis is from left to right, and that's what this adjusts. Y is forward and back, and Z is up and down. So what that means is you can hold things precisely, and you can cut, shape. The possibilities are limitless. This particular machine is a very small one. These are not super accurate. They're probably good to, within a few hundred thousandths of an inch, but a lot of what I machine is wood and plastic, so I've got a little bit of leeway anyway. So what I am doing for this job in particular, I have two vices. This is kind of an old crappy one that I got. You'll notice it's got some damage down here on the bottom. And the reason why I'm using kind of a crummy vise, I'll explain in a moment. Okay, so what I'm gonna do is I'm gonna stack popsicle sticks inside our vise here. All right, these are called 1, 2, 3 blocks. They are called 1, 2, 3 blocks because they're 1 inch by 2 inches by 3 inches. And they're right angles. They have little threaded holes. Most all lathe and mill setups use the same thread pattern. So these can be used for orienting stuff down, making sure things are square. What I'm using them for is I'm lining my edges up. I've got just a little bit of tension on the vise, so wherever these get moved to, they kind of stay. Put a little bit of tension on there. And I'm going to use a rubber hammer. I'm going to give everything just a little tippy tap and make sure everything is seated down in the vise. Now, if we were machining like precision metal parts, you would need way more setup, a much better machine. This is a very down and dirty. This is the Harbor Freight machine shop here. But what I'm gonna do is, now that they're all lined up, make sure they're nice and tight, is we are going to mill off one side. I'll reorient. I'm gonna use what's called a scale. Looks like a ruler. For some reason, when they're this size and shape, they're referred to as a scale. Looks way different than the scale I have in my bathroom, but the numbers are much lower on this. We'll make sure we're exactly 4 inches. We'll mill down the other side, and I'll show you in a moment why I specifically got out my old crappy vise instead of my better one. All right, so I'm gonna bring this down. And I have this stop block set, so my Z-axis will drop down to the right height, and the Jacobs chuck will clear the top of my vise. And I'm sure there are skilled machinists out there right now hollering at their screens. One trick that I learned from, I watch a lot of Adam Savage's videos, and if you don't, you should too. One thing that I learned from him is I've seen at least one catastrophic machining failure where my height doesn't change, so I lock that down. My direction side to side doesn't change, so I just locked it down. I'm only going to allow it to move this way because this is the direction my cut is going. I've seen instances where he didn't lock another access down, things shifted and munged the part pretty badly. So I'm trying to get in the habit as I do this of locking down whatever access it is that I'm not currently using. So I'm just kind of eyeballing this. Because again, we're not getting to within the thousandths of an inch. We're really dealing with precision more like 64th of an inch. I'm going to run it back just to make sure I got it nice and even. Shut it down. Got our quill up here out of the way. And this is why I specifically got my old vise out. You would never, ever want to do this if you had like a good vise. Be careful not to hit the vise, of course, but with a really nice vise, you wouldn't want to be rubbing a file up against it. So if you have an old vise for your milling machine that's kind of munged or messed up, I would recommend hanging on to it. We are going to loosen up that lock, and we're going to slide. And I was able to set this up pretty quick because this is not my first round on this. I'm going to take my scale. I'm going to place the stop at 4 inches. Going to lock down this axis. So the only axis I have that has any movement is this one here. Okay, and these are 4 inches long. So I'm gonna go throw these on the pile and I'll start on my next round. I hope you enjoyed that. If you want to see what real machining looks like, my favorite machining channel is hands down one called Blondie Hacks. A lady named Quinn Dunkey out of Canada does quite a bit of machine work out of her shop, and it's really impressive stuff. It makes today's work look like exactly what it is. Day one amateur hour. That's all right. Enjoy, hit the subscribe button, and we'll see everybody soon.